Go ahead, Todd.
Are you recording? Oh, we're recording. Well, hello, everyone. Welcome to Ontology Summit 2021, the session for 21 April 2021. Today's speaker is Dr. Michael Uschold. He's an ontologist at Semantic Arts. He's an internationally recognized expert with a long history in developing and transitioning semantic technologies from academia to industry. You'll probably recall some of his early papers, particularly those with Michael Gruninger, where he outlined some of the basic requirements for developing ontologies. So he has pioneered certainly the field of ontology engineering and the applications of ontologies in information systems. So without further ado, Michael, you have.
Okay, I will share my screen.
You're generous.
Yeah, it's on that kind of guy. And I will start the slide.
We're seeing your desktop?
Yep. There you go. Can you see this now?
Yes, we do. Thank you. And Michael's slides are available on the meeting page website.
Thank you. First, a shout out to Mark Fox, who worked with Michael Gruninger, and a lot of the work Mark did with Michael influenced a lot of what I did. So anyway, thanks for that, Mark. Okay, so we're going to talk about kind of the next phase of ontology, which is to say, let's put these things into production rather than just build them and publish papers about them. Now, this has been going on for several years now, but I'm just going to really describe the transition and what's going on with us and what we do and how we do it. So, quick outline. First, I'll just talk about the idea of enterprise ontology per se and how it's an answer to what we call semantic silos. Ontology is the answer to silos, but you can build semantic silos if you're not careful. And so enterprise ontology stops you from doing that. Just as our local upper enterprise ontology developed at Semantic Arts, it's widely available for anyone to use. And then we have a methodology where we start by thinking big, because we want to have the big picture in mind, but we start small to get something out the door so the client understands and sees the value. We'll talk about that in a bit of detail. And then I've just a bit of a hodgepodge of things in no particular order that are top of mind when I just sat down to think, well, what would be useful to this audience to, about our experience of building ontology. So talk about reusing things internally, using external vocabularies and ontologies that people have outside of Semantic Arts have put together. Talk about consistent patterns of style, which is continually evolving. Semantic hygiene, the idea of let's make sure everything is consistent across the board, write queries to test, to make sure that things are the way you want them to be, catching likely errors, etc. And we're moving more and more into, production systems where you have scripts and pipelines. It's not just a one-off, try this here and try that there, and then you build the next thing. And finally, another problem is once you have multiple systems, multiple people developing different data sets, different taxonomies being governed by different parties, when you depend on something else, and then that something else changes, you need mechanisms in place so everybody gets notified and everyone can do assessment of change impact and then make sure that everything is hunky-dory. So with that, I'll get started, and just to let you know, I do have another talk coming right after this. So I do have a hard stop at 5 before the hour. I should set my alarm, but that's okay. I'm going to do that. Set timer for 47 minutes. There you go. Okay. So let's go. So silos. First of all, semantic technology is all about removing the need to have silos in your organization. So why do you have silos in the first place? Well, a lot of different reasons. Can't reuse schema, so you just have to start again. Don't know what things mean, so you have to start again and do things so you know what they mean. Things are rigid. And a really critical thing is no global IDs. So even if you wanted to do everything and share it, there's no way with traditional relational technology to do that. However, what we noticed was going into companies, we weren't, initially 5 years ago, nobody still was comfortable with the word ontology, maybe 6-7 years ago. Now that's completely changed. And it was also true that we were the only people in any organization that we're doing anything semantic. Well, that's now changed. We can't go anywhere without at least one or two groups doing something. What we noticed is they're not always talking to each other. And so they're building out their own semantic platform, using their own ontology, their own terminology, their own whatever, their own styles, their own conventions. Somebody else is building out something else somewhere else. And so now you have silos, ironically, because you're using the technology that's supposed to avoid silos and you're building more silos with that technology. Don't do that. So what is that really about? It's really basically paving a cow path. So this is the famous story of Boston, where the streets are paved, literally they're paved with cow paths. So Boston was a city full of cows. And then when the new technology came along, streets, oh, let's just pave the cow path. This is not just a saying, it's literally the case. So why did they do that? Well, it was expedient. But if they had sat down and thought through the whole idea of, forget about what we have now, forget about these cow paths, what would we do if we were starting from scratch? Then you'd have a purpose-built street plan, which would probably work better. That's the idea. If you independently just take your existing silo in relational technology and change it all around for expedience, now let's use semantic technology, and you gain a number of benefits doing that. But if several different groups do that independently, you basically just have another mess. So in effect, you're paving the relational cow paths. So there you go, don't do that. So what's the answer to this? First of all, it's coordination, but you need more than just coordination. You need the technology to underpin that. So enterprise ontology is what you do to help get rid of the silos. So we look here at a kind of a abstract triple store, three of them. Looks like silos, looks just like what a silo looks like. But it's not. Why not? Because there's actually a common element. The black down below is an ontology. It's the enterprise ontology, and it's used as a common schema. So in actual fact, although these triple stores look like they're completely separate and siloed, because you have the technology of sharing URIs for both the data elements and also the ontology itself, this is not a silo. It's a uniform knowledge graph. So that's the way the ontology. That's how enterprise ontology can help get rid of the silos. You can't share a schema across multiple relational databases. It's just not possible. So let's see how that works in practice. Let's say you have, this is based on an actual study, an actual case from one of our clients. Let's say you have an HR department and they have employees and hourly workers, two kinds of workers, and they assign to offices, and the offices are in jurisdictions, which is a geographic idea. And then you have IT department. So there's users have access to databases that are installed on servers that are located in data centers that are located in cities. So we have some common elements here about place, about people. Suppose you wanted to ask about all the people. How do you find them all? Well, there's personnel that are hourly workers and exemplars. If you go back up here, you look and say, well, who's the people? There's no person class anywhere. There's nothing like that. But you look and say, oh, employee, those are probably people. User, that's probably a person. Database, no, that's not a person. Okay, so let's collect all the people together. Hourly workers, exempt employees, and then there's also buildings. So data center is going to be a building. And a user in the IT ontology is going to be a person also. And the city is located in a country. Country is a geographical item. And so what we notice here is by having this upper ontology, an enterprise-wide ontology, which has generic concepts like buildings and people and places, we say, oh, look, we can just snap those things together. They're both personnel, therefore user and hourly worker and exempt employee are all part of the same thing. So you could ask a question, where are all the personnel, and those things would show up. Similarly with building. So this looks like two separate graphs, but if you snap them all together, this is what it looks like. It's joined together as a single graph. So now you can do a federated query to identify all personnel, or you could, the other thing that's joined together is this notion of a geographical region. A home office is a kind of building, a data center is a kind of building. So this is essentially just a little demonstration of how the enterprise ontology can glue things together. again, the key critical enabler is the URIs for classes and for properties. Now, I'm not going to tell you it's easy. Don't let anybody tell you this is easy. It's not. It's a lot of work. It's a lot of coordination. You have to agree with people to not be running their fiefdoms or their kingdoms. You have to coordinate, agree on terminology, agree on minting patterns, agree on when and how to update the schema. We use an upper enterprise ontology called GIST. It has a lot of generic concepts that come with almost any enterprise person, organization, agreement, place. So these things happen over and over again. Instead of building out each thing from scratch each time, we build it once and we use it. We also axiomatize it. So you start with the existing ontology such as GIST, and then you add to it. And then you run inference, and it'll find errors that you wouldn't find if you started from scratch. So we use it for all our projects. It saves time. It's quicker than having to rethink the common things. Produces better ontologies because you have inference working based on the axioms that are in the upper level ontology. The common usage across the enterprise avoids silos. And it's easier for us internally to share the work we've done. So we'll talk a little bit about work we've done on measurements and specifications. And if I've done that work, we just had an example where one of my colleagues called me up and said, "Hey, Michael, I thought you did this measurement stuff. Can you show me where that is?" So I did, and he took it. He'll tweak it around a little bit, but essentially, if we had a completely different, upper level set of concepts, it just would work way less well. And finally, it is being actively developed. Anyone who's interested in following this, we have monthly sessions where somebody gives a talk, and you're welcome to give a talk if you're actively engaged about some aspect of just evolving it. Sometimes we say, "Hey, we're wondering about making this change. What do you think?" Okay, so this next part is just watching the time here. We're doing perfectly good. This is our current way of thinking about and executing projects. So it's one thing to start and do your own little project and a little proof of concept, but if you don't have a larger vision, then you might just do lots of little things and they won't really come together to do anything coordinated. But if you start big, you might never get to adding value. You're up in the clouds the whole time. Let's just elaborate on that a little bit. If you just think big, you lead to grandiose projects, that everybody says, "Oh, that's wonderful," but nothing ever really happens. If you start small, which is great, you can get some nice little benefits, but the end up with standalone projects and more silos because you don't have the coordination. You don't have a broader vision into which things may slot. So we have found for many years of experience trying to do this, combining the two approaches and doing them in parallel leads to a good result and creates reusability. This is interesting. Can you see this stupid, how do I get rid of this?
What is the issue?
I have the Zoom commands. It's blocking my view of the slide.
Well, we're seeing your slide.
Well, okay, so I'll just.
Can you move it out of the way to another screen, or?
Oh yes, I can. Thank you. It's easily grabbable. Okay, thank you very much. You'd think I'd know Zoom by now, wouldn't you? Anyway, okay, so we have collaborative workshops. That's how that's worked. We go on site with the client. And we have conversations, and the initial objective for the Think Big phase is to cover the maximum, a number of future subdomains with the fewest concepts. So we go into a large organization, and we say, "Okay, tell us your main part of your business," and we'll try to build the core things that glue things together. So that might be a healthcare company. And so the core thing is the patient and the doctor and the treatments and things like that. Insurance company, the core thing is the insurance contract itself. And then you have the beneficiaries, and you have the coverages, and you have the bad thing that might happen, and claims and whatnot. So for any industry, you go into usually some big picture view that captures the whole core elements of the industry and really just up to a dozen or two concepts. So the deliverable there is kind of an upper level enterprise ontology that covers the core content, the core components of the business. which is nice, but we want to start somewhere and generate some value so the client can say, oh, look at that, it's real. So demonstrate true business value by querying, across previously difficult to integrate data, so you can answer new questions. So what often happens when in a siloed world is someone has a question. It's okay, tell me the answer to this question. And then what happens is, oh, okay, I need to go to these 3 different systems, and I might not even know I might not know those systems that well myself. I can query one of them, but I'm not the wizard in querying those other 3. So now I have to coordinate with 2 other people, have them send me a bunch of CSVs, and then I have to munge that around in my spreadsheet and come up with some insights. So that's a long, complicated process because the data isn't in one place. So what we do is we build a starter ontology for a narrower domain. Like in the medical domain, we might just start with, okay, let's just set up some measurements and characteristics for blood types and for blood draws, and measure the amount of your iron amount and what your sugar glucose numbers are. And let's just start there, and then ask questions like, how long, which patients were, that had elevated levels of something were more likely to have recurring visits to the hospital for the same condition. So the key deliverable there is a triple store, which has the ontology, which is based on the upper enterprise ontology, and it has actual data. We literally ingest the data and we have some competency questions. And that's how we do the thing, the start small. So summarizing, we flush out and review the enterprise ontology. We articulate kind of the business value, put that in a bigger picture of the overall company. We have this thing called a party, which is a high-level sketch. That term comes from the architecture world, but just kind of a high-level sketch of the main things that are going on in the business. And then build an inventory of concepts that define the business. And that's kind of a place into which things may slot as we move forward with the client. Starting small. Well, now we're getting into the weeds a little bit. We inventory data sources. What data source does it? What is the schema look like? Can you dump us out a CSV? Let's get very specific. We have sessions, sometimes 2 or 3 different sessions, trying to frame competency questions. Give us something very specific. Some clients get the idea very quickly. Sometimes we have to lead them quite carefully through the whole idea because they're unfamiliar with it. And then we detail out a subdomain of the ontology. We ingest the data from their CSVs, harvest it, and put it into a triple store, and then we write Sparkle queries to answer the competency questions. And then we say, okay, what do you think? And then we'll go to the next phase. That's how we work. So that's the end of that part of the talk. So now I'm just going to go through a handful of different things that we do that we've learned over the years in the whole process of putting stuff into production. So internally, we reuse things. Lots of things are common across different companies. No surprise there. Even, a Procter & Gamble versus a medical healthcare company, you wouldn't think there's a lot in common, but actually there's a number of things that are. We mostly borrow ideas, and occasionally we're lucky enough to borrow large chunks of all of this kind of slotted in with a few minor changes. So here's one of my favorite examples, something that I've been working on in different projects for many years now, probably 6 or 8 or 10 different companies, have some aspect of, some measures, characteristics, specifications and observations. It's kind of a nice little bundle. So we first encountered this at Procter & Gamble, formulas and recipes for industrial manufacturing of stuff, say, for example, Head and Shoulders shampoo. So you have it's a specification for what goes in and what order in which you do things. Electrical power products, so voltage regulator. What is its rated voltage? What is its size, weight, shape? So these are specifications of what should be. It's not the actual product itself. It's not picking up something in your hand and weighing it or putting a voltmeter on it and seeing when it breaks. No, it's a specification of an intention. It's a test to see whether an actual physical thing meets a specification. Something similar on a totally different line, but using the same idea of a specification. Price assessment. Some companies sell information. They sell information about what they think the interest rates are going to be, or what they think the price of Brent crude oil is going to be, or what they think the price of gold is going to be. And people will have their whole business is to provide estimates of that sort. And these are now products. So so if it's a product, you have to specify what you're getting for your money. And that's essentially a specification. Medical observations. I mentioned that a few minutes ago. Blood tests. What's the amount of glucose in your blood? Dates, times, etc. Economic indicators. What's the price of olive oil in Greece this year? And that's going to indicate the things that are downstream, maybe uses of olive oil. If there's a shortage of olive oil, then maybe some other industry is impacted. And we also use similar underlying representing the characteristics of things. So electrical power products, they have characteristics. They have weight, time, voltage regulation. But an industry, like you just look at the insurance industry, that also has characteristics. And so this notion of a characteristic underlies a lot of different enterprise ontologies that we've built. A couple other examples. Something we see a repeating pattern of hierarchies of categories and types. For example, product hierarchies. Smartphone is really a category. You can't go into the store and buy a smartphone. You say, I would like a smartphone, please. They say what kind. And you could even say, I want an iPhone 12 Max or whatever they're called. That's not even enough. Oh, what color? What weight? So at some point you get down far enough where it's actually a catalog item. But the things above it are categories. And so this shows up a lot. Product hierarchies, commodity hierarchies. And we just see the pattern and we recognize and say, oh, this is one of these things. This is just an example. Olive oil, vegetable oil, food and beverages. This is somebody's idea of a food hierarchy, and a little minor portion of a commodity hierarchy. Silver, which is a precious material, metals, which aren't specific to energy, oil would be in the energy industry. Another common pattern is what we call temporal relations, what relationship held over a period of time. So when was when was Jeff Bezos the CEO of Amazon? I think he's stepping down soon. So there's a period of time when he was the CEO. Or when was this person heading up a committee? What was the dates of when Boeing had the registered address in Seattle versus now its registered address formerly as a corporation is in Chicago? Or when was the USSR a thing? It's not a thing now, but it's historically, it had a date ahead of time. Yugoslavia, Myanmar, names changed, countries evolved. Some of our clients need to track that. We are moving towards, at the request of some of our clients, they said, hey, why aren't you using SCOS? We use SCOS. Why don't you use SCOS for the hierarchies? Why don't you use SCOS pref label? Why don't you use SCOS alt label? And we said, okay, we don't have any particular reason for not doing it. It's just we've been using RDFS labels for a while, and if you want us to use SCOS, we're totally happy to do that. So then we realized after using it for a while for some of our clients, we like it. It's nice. So we recently migrated just from the annotations in the RDFS namespace to the SCOS namespace. We have had occasion to use geonames. So there's a free version of it. I don't know that we imported the ontology in toto. It's a quite small ontology, but we certainly looked at it and we borrow from it. We have had occasions with clients where they wanted to use medical taxonomies. And sometimes we just borrow the ideas. Sometimes we link things up. Like, for example, a medical taxonomy for diseases, we'll just have a class called disease, and then instances of the disease will come right from the medical taxonomy, and then we can snap things together that way. Using existing vocabularies and ontologies. So the exception is to pick something up and use it directly. Most reuse is the ideas and the patterns. For example, FIBO is a tremendous resource for information about how to model something, but FIBO as a thing, it's quite large and unwieldy, and the chances of having it be useful by just importing the whole thing and starting to use it, are not high in my view. But it's a great resource. and people are using it. You don't have to use the whole thing, so it's a good thing to have. We look for inspiration. So if we need to model, certain complex kind of financial instrument, we'll say, well, Fibo probably did that. Let's go look, and we get some good ideas there. Now, there are gotchas. So this is based on a lot of experience. When we see other people's ontologies, they say, hey, look, we've been doing some all. What do you think? And we have to be nice. What we often see is what amounts to a transliteration from a relational schema. So you look at it and say, from my perspective, and with the semantics background and logic and OWL and everything, I look at it and say, that's not even an ontology. It is strictly, literally an ontology insofar as it's an instance of all ontology, but it's really just a transliterated relational schema. It's a bit analogous to writing what amounts to Fortran code, but using the Prolog language. Someone who knows Prolog would look at somebody who only knew Fortran and just learned Prolog, and I would say, oh my God, that's not a Prolog program. That's ridiculous. It's somebody who's writing Fortran, but they're using the Prolog syntax. It's a bit like that. So it's a relational schema using all syntax. Some of the tools that can be useful to get started in certain things. I'll come back to that in a little bit. Another very common thing we find, even with W3C sanctioned ontologies, you have over-constrained domains and ranges. So the one example we came across, we worked with a company in the media industry, and we thought, well, they said, hey, you should use the media ontology from the W3C. And we looked at it, and I forget the exact example, but every single property had a domain and range of the media object. Common properties like has author. Well, you know what? Not everything that has an author is a media object per se. So in other words, if you actually adopted that ontology, you'd be very restricted. So we basically said you can't use it. A lot of times, so-called ontologies are really just glorified taxonomies. It's just a class hierarchy without any restrictions, no real meaning to get your teeth into. We also see vast amounts of property proliferation. People seem intent on creating a new property for every different kind of thing that the property can connect. So car has part wheel, car has part driving chassis, truck has part car. So you don't want to have lots of different properties where the name of the property suggests the domain and range, and they have actual different domains and ranges. Part of is a generic thing, and you can use it to connect all kinds of different sorts of things. Another thing that we've seen is proliferation of classes. There's one example of a disease ontology which has 300,000 classes. This is what we would call a glorified taxonomy. And representing things as classes, you can do that if you want to, but we like to keep the class hierarchy than that. And the other thing to keep things separate is who's governing the thing. If you just pile in all those classes into the ontology, then you don't have separation of concerns. The reality is we have the ontology that we'll build for a healthcare company. And then someone else is going to be monitoring SNOMED or whatever it is. They're governing that. So we want to link with it, but not fold it right in directly. And so we find that it's better to have, like disease, it's better to just have a class called disease. Or for a product hierarchy, instead of having classes all the way down the way, just have categories of products and have individuals that are linked by, say, goes broader than. Sorry about the coffee. Another thing that we're doing a lot in recent years is consistency in patterns and style. So we have a style guide, and just, by the way, anyone is welcome to join. Just if it's public, you can download it and you can join. The issues are now public, so anyone can create an issue on our GitHub site. So we have a style guide that we have published for GIST, and we use it in all of our internal ontologies and our ontologies for our clients. Here's just a few highlights. We always use the EDM Council's RDF serializer. In other words, if 3 different people are working on an ontology, and one is exporting from top-rate composer, one is exporting from Protege, and one is just writing a text file in Emacs or Word, then it's going to be a mishmash. You can't tell the difference. So you need a serializer to make anybody be able to compare their work with what others have done. Very important. We now, as I said earlier, are always using SCOS annotations if possible. There are a few cases when SCOS doesn't provide quite what you need, and then we'll use the other annotations. That's all documented in our style guide. We also have agreed to use certain camel case conventions. Some of them are completely standard. Everybody uses them. For example, classes are upper camel case. Properties are lower camel case. But then there's other things like acronyms, abbreviations. What do you do if you have something like an acronym USA? We decided, we had long conversations about this. Multiple people had opinions. It's not something that's terribly important which way you go, but each option has pros and cons. For example, if you just leave the USA as uppercase, then you can't tell when the next word starts. If you use an underscore, maybe you have underscores using that in a special way to do certain kinds of munching around with text and verification. So we finally agreed to use this, where we give up on seeing the familiar uppercase, and then we just use that. So this is what we decided to do is not important, but just the fact that we had a decision, and now everybody uses the same pattern. We have introduced a separate layer for enumerated lists. Like, for example, suppose something has degree of confidence and you just have 3 values, low, medium, high. Well, what is that? Well, it's just a bunch of individuals. You create a class called degree of confidence, and you have 3 instances, low, medium, high. But you can have a whole full taxonomy, say, of product categories or commodity types. And we have a separate layer for those, mainly because they're typically managed by someone else. The company is going to decide, well, we want a new value, low, medium, medium, high, and high. Or we only want 2, good and bad, or low and high. So we don't govern that. So we like to separate out things that are governed by different groups or different people. We also have a separate namespace convention for each layer. We'll see an example of this in a couple of minutes. So the ontology itself has a namespace convention, and then the data layer has a namespace convention, and then the taxonomy layer has a namespace convention. We also have this idea of a midfix, which I'll demonstrate in a moment. So there's prefixes, and then there's the fragment, but we introduce something in the middle as a convenience for people. So here's our big picture. You've seen the first 2 layers. This is just the ontology layer. So for example, you might have documents and people and topics and countries and country groups and whatever. So it's the ontology layer. And then the familiar linked data layer. Here's the actual document authored by an actual person who is an official for an actual country, who is a member of a group of countries, all of whom share a common characteristic. So this is all commonplace. But what we do is we say, well, where do these values come from? Monetary unions, advanced economies. These actually are kind of groups of values. Sometimes it's an actual taxonomy, like geography. So we maintain these separately. So document types are just a list. And this document types might be a structured list of taxonomic condensed, or it might just be a flat list of 7 different values. So we have this intermediate layer. And the reason for the intermediate layer is as again I said, separation of concerns. Usually these things are monitored and governed by a different body than the people who are monitoring and governing the ontology. So here's just an example. This is an economic indicator, the price of olive oil. So notice what we've done here. This is our idea of a midfix. So this is the identifier, PZP, blah, 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 blah. And just for the convenience of the human, munging around in Sparkle and writing Tarkle triples to look at things and say, what class am I? So this is what we call the midfix. So we start all our individuals with an underscore, a leading underscore, followed by the name of the class that it's an individual of, followed by, what would normally be just a fragment. So this is an economic indicator. It has a pref label, so we're using SCOS. And then it's in 3 categories. Then again, using the midfix. So olive oil, what's olive oil? Olive oil is a commodity type. What is prices? Prices is in a sector. CTS is just a specialized name of some subset of sector. Somebody's governing a set of sectors. And also there's topics. There's a whole bunch of topics, dozens, maybe hundreds of topics, and this is just one of them. And then of course we have a description. But the commodity type is sitting in and then hierarchies. So for example, olive oil is broader than vegetable oil, which is broader than food, which is broader than food and beverages. Sorry, has broader. This is unfortunate naming of the property. You know what I mean. So here's then the triples. So commodity type of vegetable oil is a commodity type, and it has a broader term, food. So this is just how we build things up using those 3 layers. And the prefixes, let me highlight that. So the D prefix means data. The X prefix means the intermediate taxonomy layer. And the EO prefix means the enterprise ontology layer. And there's some prefix that indicates something about the client. Okay, so that's that. So now move on to semantic hygiene. How are we doing that time? We're doing fine, I think. Yep. So there's lots of different things to check. We like to keep everything neat and tidy and clean. So what artifact is it relevant to? Are we doing checks in the taxonomy layer, on the ontology layer, on the data layer? Are we doing taxonomy checks that apply across every ontology or every data set, or are we doing something that's domain dependent? Here's just a couple of examples. There are many more. You just look for things that are mistakes. Is there a named inverse in the ontology for a symmetric property? That doesn't make sense. Has border is a symmetric property. So if Canada borders US and the US borders Canada, the property going the other direction doesn't make any sense. So there shouldn't be such a thing. Similarly, properties transitive and domain and range have to be the same class. If they're not, that's an error. So we have dozens of these checks and we just run them to find errors. We also run more sophisticated checks using Shackle, and we have a regex wizard. Do all kinds of cool stuff to check, ensure style conventions for casing. We like to use human readable labels for our IRI, so the pref label is always aligned with the IRI fragment. So if the country code is the name of a class, and we have country code, in camel case, then the label has to be country space code, where there's some kind of white space in between. We can check for that. Here's a really powerful query. If you have a triple star and you want to find some errors, almost certainly you'll find one running this query. Look for all the triples and look for all the subjects of all those triples and say, hey, does any of these subjects not have a type? That you might not have loaded the ontology, or somebody might have created that thing somewhere else, but everything should be typed. This almost always reveals some mistake you've made somewhere along the line. Now, on the domain dependent side, focus on a particular subject area and concern of your client. There's endless things to check, and there's no shortage of new queries you can write to check for things that might be problematic. And we ask a lot of questions. We don't understand the data as much as the client does, but we learn more and more about it, and we say, hey, I just ran this query because I was curious, and I found out these 17 examples of duplication. Is that an error, or is that just an exception which you know is there? So that goes on a lot. Now, mostly we use Shackle for this, sometimes Sparkle, and occasionally we will write specialized code for certain things. We also have these queries all sitting in folders, and we run scripts that call, that just go into a folder and run all the queries in the folder. And that way you just kind of move things in and out of the folder instead of changing the code. Okay, last major topic is change management. So change management is hugely important. The whole problem of ontology versioning is probably never going to be a fully robust solution that does everything you want it to. But the bigger question in the context of a customer solution and using semantic technology, what happens when a new version of some information artifact is released? What other artifacts could be affected? So there's 4 kinds of artifacts we highlight here. Ontologies themselves, this software that does processing, maybe creates a data set. Shapes, which is the Shackle shapes to do the consistency checking, and taxonomy. So for example, a shapes document is going to depend on the ontology that whose classes and properties the shapes document refers to. And if you change the version of the ontology, then the existing shapes might not be valid anymore. You might have changed the URI, for example. So what other artifacts could be affected, and what changes need to be made? Who's responsible for making the changes? Are they notified that the change is made? How are they notified that the changes they might have to make some changes? And how to maintain version compatibility? How can we track all these dependencies? It's all about tracking dependencies. Principles and requirements. So I will meet me and a software developer guy who's also a Sparkle wizard developed this. So he has a ton of experience in what sort of sophistication goes on in version management for software, and we adopted some of those principles here. So the basic dependency goes like this. You state these dependencies in a triple in the information artifact. So a particular version of an item depends on another item. How does it depend on that other item? It requires that item to have a version which is a particular value. It must be this version, or it must be within a range of versions. It can be anything from 2.3 up to 3.0, but it can't be before 2.3 or after 3.0. That's the basic statement of a dependency. There's also, we generate provenance for data sets that were created. So a data set was created, you run a piece of software. What versions of what items were used to generate the data set? What software application was used? What was the data source that was ingested? From which output? Is this a fresh load or is it an incremental one? And when was it generated? Simple date stamp. And then here's some principles and requirements, not all of which I understand the nuances of. If you're a software developer, some of this may be more obvious to you than others. We decided that the data sets themselves don't need to have versions, because data sets change all the time. They change almost instantly, any moment almost. Sometimes the data set could change. But they use versioned artifacts to create them. The idea is to automate it as much as possible for quality and efficiency. A non-breaking change should require minimal efforts. So you should ideally have to do very little for non-breaking changes. Just build into the infrastructure systems for that to happen. We did that. Another thing is, the question really is, what things should have versions and what things don't need versions? And then you scratch your head a while and think about it and say, oh, it turns out that only the things that are delivered independently should have their own version. Otherwise, there's not a need for it. I can't explain the details of why that's true. That's just what we landed upon. Another thing was, we often separate out ontologies into different components. For example, I have a separate ontology for measures and specifications, and I kind of use it for different clients. And if I bundled that all into a single thing, then it would be inconvenient. But sometimes I don't. But we version 5 or 6, mutually importing ontologies as one. It's handier than having to separate out a different version of purposing one, when essentially you think of them as a unit. You just have them divided up into modules for convenience. What's the update process? First of all, there has to be a mechanism for people who curate the information artifacts to learn about changes. So say a developer makes a change. The curators determine the impact on the artifacts and on their governance. So there's a notification. Somebody makes a change. The curators sign up to some change notification mechanism. They determine what the impacts are, what changes need to be made, if any. Often no changes are needed. You change a URI, but if you don't have it, if there's 150 URIs and you're only using 72, chances are you don't have to update it every time. And then you go ahead and make sure that the updated, so if you make changes to the ontology or to some information artifact, what you depend on might change. So you have to change the actual dependency statement. In other words, if you used to say it has to be between versions 2.3 and 3.0, but a change happened in version 2.7, so 2.3 is no longer any good. So now you have to update that dependency statement to say it must be between 2.7 and 3.0. That's what we mean by updating dependency. So you make the changes. Here's just an example. So let's suppose the IRI of a concept in intelligence unit. Maybe it was a typo. Maybe the name was confusing. Maybe the client said, we just don't like this name. And we want it changed. So we change the name. This is compatibility breaking because it could require changes. There are lots of downstream impacts. People who write shackle requirements, people who write Sparkle using that IRI, any number of things need to change. So that could require a major version bump. What I didn't mention, I should have at the beginning, and there's something called semantic versioning, which is number for major version, minor version, and patch version. We kind of build off of that. So new version number is given to the versioned ontology or the collection of ontologies that's versioned as a unit. Then you identify all the versioned items that are dependent on the versioned item that changed. And the curators determine the impact of any versioned items that are under their governance. And as I said, quite often, if it's just a minor change or 2 or 3 different things, a lot of the people who govern these artifacts, no actual changes need to be made in their particular case. But you have to have this system in place to give you confidence once different things are getting loaded into a production triple store from different places. So we have this mechanism currently in production. We're going to write a paper and give a talk about it at some point, but we want to align it with some of the W3C data sets, Provo and things like that. So we invented a few things on the fly, and we know that there's possibly a better way to do it by being more aligned with standards. Another thing, we're getting near the end here, scripts and pipelines. So when you just do things making proof of concepts, you can do a lot manually, and there's a lot of scope for flexibility. But the more you get into production systems, you need to automate more and more and more. So as I said before, we automate the hygiene queries, we automate version validation, we have scripts and pipelines to drive, sometimes complex series of things, different groups of CSVs come together and you run a bunch of different Sparkle scripts to update everything, and you want it to all happen by pressing a button. Now here's one thing that I'll report, which is kind of interesting. Happened a couple of years ago. So I call this speeding up a data refresh. So what happens is we're with a client and they have a relational database. It was really a ton of interconnections. And in order to get the CSV that we needed, that had the information that we wanted, from which to make triples against the ontology, he had to run a query, a very complex query with joins everywhere, that took 12 hours to run. And after that 12 hours, they would dump a CSV to us, and then we would use that with Tarkle to generate triples. So we had this idea, the royal we, my boss and my colleague, had an idea. Well, let's introduce a new step in the process. Let's try to avoid that 12-hour nasty query and do something else instead. Let's do this transliteration thing that I said you should never do and call it an ontology. But there's an intermediate step. Essentially, you take the pieces of the relational model that impact what you care about, and you do a transliteration. So you create just ontologies that you shouldn't have, but this is just for an intermediate purpose. It's essentially a pseudo-ontology. So you create that, and then you use Tarkle to create triples against that pseudo-ontology. So there's no real ontological structure. That's why we use the term flat. So now we have a bunch of flat triples. And then you use, to avoid all the joins in the SQL query, you write a Sparkle construct query to convert all these so-called flat triples into proper triples that go against the semantic ontology. So that was pretty cool. All this is automated in a pipeline, and it was a dramatic increase in efficiency. It went, the whole process, I don't know, these numbers aren't exact, but the whole process went from something like over 12 hours to around 1 or 2. That was pretty cool. Now, this is a bit of a one-off, and I wondered, well, gosh, how come we never did this before? Is this something that's just a weird little one-off with this client? And it turns out that we're facing something else that we might end up doing this for another client. Anyway, that's just a little something that you probably didn't hear from anywhere else. If you did, I'd love to know about it. That'd be kind of interesting. Okay, summary. And it looks like we're doing good on time, although I didn't leave a lot of time for questions today. Sorry about that. Maybe there's a bunch in the chat. So putting things into production is a whole new world compared to proofs of concept. The name of the game includes things like reuse, consistency, checking, and automation. And there's probably a long list of questions in chat which I haven't been paying attention to. Does someone want to pick and choose, or should I pick and choose?
You can pick and choose if you like, Michael, but I have two questions before you go picking and choosing.
Okay.
One, you mentioned in your talk about layers of the ontology. Are those different ontology files or just different IRIs in the same file?
Oh, you mean the different layers? It's more of a conceptual thing. The taxonomy layer uses the X in the namespace,
Oh,
and it has drop-down lists. It has lists of flat lists of enumerated values and also taxonomy.
another question for the clients that you've been working with. Do you run into issues of their firewalls? That is, are they?
That's an interesting.
Yes.
Yeah, we do often. In recent years, we're doing more and more of our work behind the firewall, and so it's inconvenient. And sometimes they require us to use the laptop. It's just part of doing business. It's not so much a problem as just one more thing you have to do. It slows things down a little bit compared to doing everything outside the firewall. But things are moving in that direction. Early on in the early phases of a project, we often can do everything on the outside in terms of ontology development. But when it comes to the actual customer data, like in the medical domain, we had to do everything behind their firewall because there's patient data and everything else.
Does that change the way you construct IRIs?
No, we do. We're consistent in how we do that.
Okay, thank you. So pick and choose. There's a lot of questions there.
Well, okay, let's see. I'll just go in order. Let's see. How do I handle duplicated triples among different silos and reconcile if their meanings are different slightly or vastly? From Ravi Sharma. That's one of those things where you write queries or often you just stumble across problems like that, and then you write a query to see if there's others lurking. Let's see. Well, somebody. How many iterations this is a good question. How many iterations with SMEs from different areas of enterprise are required to reconcile think big items? It's an evolving process. So we have to think big. People get the big idea. They sign off on this broad picture. And then, if we're fortunate and we do work that the client appreciates and their budgets align with the stars, then we continue the project. So how many different iterations? It's really just ongoing. So I can't give you a number really. Next question, they're all from Rob. Let's see if it's from somebody else. Terry, slide 33, is using intermediate triples better than improving physical structure of the relational data? Slide 33. Oh, this is this last one. Well, yeah, we don't have the option to improve the physical structure of the relational database. This is a production system. And what I've learned over the years is I've never did any SQL before, and I know very little about relational from direct use. It's more just talking to people. That's not even an option to improve this, to change the relational database. Relational database schema evolve over time in such a way that at any given time for any relational system that's been in place for a while, 50 to 70% of what's in there is junk. It's just left behind. They never cleaned it up because they're afraid it might impact on some application somewhere. So that's basically not an option at all. Let's see, Gary, we can perhaps spend a little time in our synthesis considering the landscape. Oh, the landscape of pseudo-ontologies. That's interesting. Some are used for technical convenience, which is what I just described a moment ago. There are probably several examples as part of meaning. Well, here's an example. The company co-founded by Juan Cicada, they had this process of automatically creating what I call a pseudo-ontology. He called it a putative ontology. And he said, it's really handy to have this, and some people make use of it. So that is an interesting question. Janet Singer, as I recall from the Knowledge Graph seminar at Stanford last year. Wow, cool. I said I preferred speaking of generic conceptual schema rather than ontology. Maybe that's just a terminology thing inside a company who isn't familiar with the term. Our continued attempts to oh, there we go. So it is about terminology. Are the continued attempts to popularize the ontology label a matter of state and cow paths? Well, that's interesting. It happened to be laid decades ago. I'm not sure I understand that question. Do you want to jump in and clarify what you mean by that, Janet?
Well, just because people cannot agree on what an ontology is. And so a lot of effort is wasted on that issue. Whereas what you presented here is quite clear. And so I'm just wondering if the ontology label is an obstacle to this kind of workflow that you're talking about. But it might be too late. We might be in Boston and
you know, there was a huge amount of effort and dozens of papers written about what is an ontology. And I think it was an important phase to go through. And now I never really worry about it at all. I don't worry about the label. People generally tend to know what it means, so it doesn't seem to get worse. And with that, I need to jump off to another call. Thank you, everyone.
Well, thank you, Michael.
You're welcome.
That was very good. Excellent.
With that, I will stop share and jump off the call.
Have fun out there.
Will do. Thank you.
Thank you so much, Mike.